So in this video, what I want to do is I want to go ahead and actually define what a limit actually is, graphically in this case, and what does it mean exactly in terms of calculus, in terms of what mathematically what does it mean on the graph. So here we have a function. We have f of x equals x squared, and what I'm going to do is I'm going to graph that function, but it has a restriction here. This is a restriction, and it's such that x does not equal 2. So what that means is whenever I plug in x equals 2, so if I actually do kind of a little table here, and what I'm going to do is I'm going to do x and y. When x equals, let's do x equals 2, right? And when x equals 2, so if I say f of 2, for example, f of 2, well, that's just going to be the quantity 2 squared, because really, like I said, my function is f of x equals x squared. I just plugged in 2 for x, right? In terms of this, right? And that's an x, by the way. This should be x squared, like that. So then I say, well, what does that give me, right? This, in and of itself, is just going to be 4. Now, when there is a restriction, this means that we are not going to define. So when x equals 2, y equals, or f of x is 4, but we are not defining it there. So what does this mean exactly? When x equals, when f of x at x equals c is undefined, we denote that with an open circle. So if you remember from algebra, when it is undefined there, we go ahead and put a circle here, kind of an open dot or open circle, right? Now for the rest of them, of course, when x is equal to 1, so we know that, we would say this is undefined because it's not defined there. Even though we know that there's an open circle at 4, it's still undefined because f of 2 does not exist. Now, if I do at x equals 1, then I know that when I plug that in, f of 1 is going to be the quantity 1 quantity squared. Now remember, we're working with x squared, so I'm plugging in x equals 1 for this, right? For this stuff here. So then when I do that, that gives me 1, right? So I know that for this part, it's going to be 1. And then, so we're going to put a point at 1, 1, and denote that right there. Now, for for 0, f of 0, so if I kind of go ahead and go over here, and I say, again, f of x equals x squared, this means that, so basically we're going to plug in 0, so f of 0 is going to be equal to the quantity 0 quantity squared, which is 0. So we again are going to go ahead and plot that right here, and it's at the origin. Now when x equals -1, we know that f of -1 is really going to be the quantity -1 quantity squared, which is just really equal to 1. So, we know that it's going to be denoted by this, right? Give me a second, guys. Okay, sorry about that, guys. So we know that it's going to be denoted by x equals 1, right? Or, I'm sorry, y equals 1. So it's going to be at negative 1 comma 1 here. And then, so we kind of have right here. And then negative 2, so at negative 2 again, at negative 2 it is defined. We have the restriction of x does not equal 2, so, but we do know that at negative 2 it is defined. So if we again look at our function, f of x equals x squared, f of negative 2 is going to be the quantity negative 2 quantity squared. Now this is 4, right? So then we, of course, this looks like a parabola. So we're going to draw kind of this smooth, I'm doing my best to draw it here, smooth curve. Now this point, you're going to go through like this, right? And we're going to put 2 arrows like that. Now, if we're going to talk about limits, if I say the limit as x approaches 2 of f of x, I'm sorry, of the function x squared, we know that although f of x is not defined at x equals 2, the limit still exists. The idea is, if I grab my pencil and I just kind of go tracing this line here, this curve, where the idea is, what am I approaching as I get closer and closer to 2, right? Even though it is undefined, we want to know the limit. The limit is really all about, what am I getting closer and closer to as I approach an x value? It doesn't always mean that that x value has to be defined for f of x. So that is really the idea of a limit. A limit basically means, what am I approaching from the left and the right as I get closer and closer to a specific x value. So of course, we see here that we're getting closer and closer to this, this value of 4. So therefore, thus, we can say, thus, the limit as x approaches 2 of x squared is equal to 4. And like I said, even though it is not defined at x equals 2, right? So that is kind of something we have to be careful with, and that is the idea of what a limit is. It's about, what is my behavior of the function as I get closer and closer to a specific value, as x gets closer and closer to a specific value, right? What is the limit of my y value? Something like that, right? I really hope that makes sense. But it's really just end behavior, right? It's connected to end behavior. But with that being said, guys, that is really all for this video. I just wanted to quickly define what a limit is and what it means to take a limit of a function. So with that being said, guys, thank you so much for watching, and also please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.